worth. And what I kind of do is go around and help businesses implement data integrations with things like Salesforce. One client I'm working with, we do some things with like shipping logistics. One company has a very small project where we're simply integrating with Google API, calculating distance between 2 points so that they can do estimates on distance and travel time and things like that, and they incorporate that into their equations for how they estimate what they are going to bill their clients. So small projects, but there's kind of like the core pieces that I always keep in the back of my mind. And because these are very data intensive and also kind of non-deterministic type projects, there's certain kind of patterns and practices that are kind of good to follow. So I'll at least kind of start going through that. And then at the end, I do kind of have some brain exercises just to kind of like walk through the process of what I would do. And some of the tools I use, I know the tools I use aren't the same tools that you're going to be using, but much of the big concept will apply to the different platforms. And as you get into different programming languages, you'll kind of figure out that most technology borrow from each other. So if there's something that is really cool feature on one platform, give it a few years and it'll make it over if it doesn't already exist. But so I'll kind of just touch on the major topics on this, and then yeah, so let me share my screen. So yeah, I got my master's in 2013. I finished school, kind of took a break from school and the work world. I kind of started and went back and finished it about the time that my classes were going to expire. So kind of one of those things where I probably shouldn't have stopped, but I just got so tired of school. But now I'm married. Some of our pastimes we enjoy, kind of picked up kayaking and started going fishing. I still play video games. So try not to nerd out too much with programming, but because I'm a small business owner, it really eats up a lot of your time, but it's very rewarding at the same time. So I do full stack development. So I am kind of aware of both sides, but where I think because of backend is a very controlled environment, because as developers, we have the power of saying what resources we need, can design the architecture, can tune things, that we don't have to worry about interfering kind of technology. When you get to the front end, there's such a range of computing power. People have plugins that just do really obtrusive things to the browser. So it's almost most of the optimization you kind of want on the back end and leave most of the front end very light unless you are able to get more control in that environment. Even like getting feedback on things that are happening on the front end, because you have such a range of different levels of users, you can't rely on them being able to get you good feedback. So it makes the work on the back end that much more kind of needs to be well thought out about how you track things, even coming from the front end to the back end. So so there's different implementation strategies and infrastructure parts. So in the modern kind of world, we have Azure, AWS, Cloudflare, all these systems. They're made to be built for very small purpose-built solutions that can scale and also grow with hardware. But it's just you build small solutions that just tackle small parts of a big problem. So that's kind of how we moved. Maybe 10, 15 years ago, kind of where I started development, I kind of was in the middle of it. So you'll hear the term kind of monolithic applications. So these applications were built one solution. They had the front end, back end, all built together. So they were very restrictive, and you could have processes that did things that would kind of starve out the rest of your service you're able to provide. So so what are the major components that goes into building the backend? So you have your frameworks. So there's the layer, and we're kind of talking about web frameworks here. So I'll kind of set up the type of environment. So front end website. So going with like Spotify, very lightweight front end, has widgets that interact with some servers. Some are permanent connections using WebSockets, so it sets up a stream. Other things are like requests, like when you pull your playlist, it's just going to be a short burst of a lot of data, and then your UI just kind of keeps it. So that is a lot of interaction with the server, which could be 1 to n number of servers. So you could have one API that deals with only playlists, one that probably only deals with streaming music, others that are doing with the artist pages. So really you have already there 4 parts that kind of have to talk together, and also are trying to give a good, quick user experience on the front end. So each of those on the back end, each of those APIs probably, they own their own part of the data model. So depending on what companies you work with, that data model could be shared in one database, or as things have matured, they own their own world, and the only way to interact with that data is going to be through that API. So there's many different pictures. So each API has what we call a stack, or kind of like it's built of frameworks, database stores, kind of the memory management, and the code base, all on that. So the first part is the kind of, I don't know of a great term for it. So we'll say it's like a web application framework. So for .NET world, that's called Web API. If you're in Python, a couple of popular ones are Fast API or Flask. So basically, these serve as the gateway between your client and your backend. So they do things like establish security between your client and the server. You can restrict, it's called cross origin. So you require that the URL of the person sending the request matches a pattern on the back end. Otherwise, it throws it away. You can do things like security certificates. There are things called JWT tokens that protect your API. So basically, you pass your username and password, generate a token, and that gives back to the front end. So all of these things are important because it's your gateway into your application ecosystem. So this is the first tool that we have to load balance and kind of orchestrate where messages get sent. So smaller companies don't need to worry about this so much, but as you get to bigger companies where they have multiple servers that do the same things, then you have to think about how you distribute those across your all your implementations that consume those messages evenly and try not to starve out messages. So you have to measure, let's see, on this slide a long time. So this is kind of the first part, scalable services. So you're trying to build things in such a way that as your load grows, you're able to have good throughput and good response time to the front end. So the things like the load balancing, also making sure that your APIs only handle a small part of the bigger picture. So in the case of Spotify, you only want the playlist service to handle playlists. You don't want it to start also streaming, because that is a huge amount of resource utilization that really could affect everything if you're restricted to that one environment, and it's going to eventually starve out one or the other, or just deadlock it. So a load balancer is an example of a message queue and event. So these are ways that we can submit requests, and I don't know if you're familiar with what a queue is, but it's just like standing in line, first in, first out. Basically, you accumulate these messages and have consumers on the end that just kind of slowly take these and process these. So that's another major player. So database optimization. So as full stack developers, we have a lot of skills and not necessarily very specific skills. So the database thing becomes very important to understand and know ways to make your data access a lot faster. So I'll kind of walk through the tools here in a little bit, but because this is our permanent storage, and a lot as we get to designing our data models, multiple tables represent one thing, and as you bring those all together, you can either do that efficiently or inefficiently, or help the system know how to piece that data together so that it is as efficient as you can be. And again, a part of good code design is that you want good code coverage. That's probably something stressed a lot in your class, but even if you don't get to test, or some companies, they don't prioritize this as much as they should. So especially the smaller ones. So, but making your code testable so that you can just really dive into small chunks. It changes how you code, because you don't want to have too much happen in one bit of code. Otherwise, your brain fries. And then you want to find ways to measure your code. There's a lot of tools out there that will go in. So you want to be aware of the time between when you enter and exit functions. You don't always have to be aware of this, but as you start debugging, it's important. So think about things like the functions, your overall requests. Whenever you send a message, how long does it take to get a reply on the browser? A lot of those things, kind of like I mentioned before, is out of your control, but you can measure the in and out of the total request. And that a lot of times is a good indicator where that shit should sit on your ecosystem. What other things? So your database queries, those should also be measured. So all these things incorporate, and you'll hear the term telemetry. So there's platforms out there that help you log and track this data very robustly. And I will say bigger companies prioritize this type of logging and kind of note taking a lot better than the small mom and pop shops. So there's such a range. So depending on where you land, just kind of knowing what tools are out there is going to get you a lot further. And even if you can't implement some of these really nice but robust solutions, you still have to kind of pick and choose what tools you use to kind of investigate. So as in our coding environments, what type of tools do we have access to? So one of the most basic fundamental one is timers. So the simplest way to put it in is make a timestamp of when you enter a function, take a timestamp at the end, and then you do just calculate the difference. Very basic, doesn't take a whole lot of code, and you can just throw it in there in a couple minutes. So it's great when you're really trying to dig in and understand where things are going wrong, or where things are slowing down, but you don't know what part. Build the timer in, spit out to the console. There are a lot of little things you can do that don't require you to register events with the database and stuff like that. So use your IDE as fully as you can. A lot of them will provide you tools that will actually do the timing part for you, but there's sometimes when that's a little bit overkill. So always take a little bit of time, learn something new in your IDE that you're using. I use VS Code and Visual Studio a lot. VS Code isn't as robust on this part, but Visual Studio can let you run your solution. It will take it'll take the runtimes of each function, and you can drill down, see what is taking the most resources, and just make you aware. Be always trying to get familiar with your debugger. So I've met a lot of earlier on developers that will choose to write to the console versus putting breakpoints in their solution and dig it in. So the debugger gives you a whole lot more robust feeling of what's happening in your memory. You can look at variables. You can set conditions for when things are true that it'll breakpoint and stop the execution of your code and let you just kind of line by line step through it. Sometimes the only way to really learn what's going wrong, especially if you inherit projects that are not implemented very cleanly, you just have to go line by line, walk through it, and then put in the tooling that you need to help measure. And then logging is a big thing. So you can do anything from just writing stuff to a file. That's kind of the cheap solution. A lot of packages will write to the database for you, so you can start building out a more easy queryable solution. And in both ways, you get the same amount of information. It's just when you write to file, you can't perform really optimized queries to look for things. You just have to, search and replace, or write applications that know how to parse your file and then give you a better user experience. And then kind of the first step to really writing optimized code is as we write new stuff is to make sure what we do is the best possible way. So anytime you do loops, make sure that you have good break exit, good code exits. Don't make loops that do one-off queries. So if you're trying to query a table that's got 100 rows, query the 100 rows first. Don't write a loop that selects one row at a time. That's it, because of just think about the little things that have to happen. If the connection's not open, you have to open it. Then you send the query, which is then compiled by your database, and then return to your solution. And then that step, once it's in your solution, if you have an ORM, then that gets translated to object. So it's better to do that before. And it's little things like that that can save you a whole lot of heartache down the line. So, and also always think about whether or not, if a table could grow infinitely, then always look to include paging, and ways to limit how much data you're taking at once. So So kind of think in terms of your runtime, but also your memory. So we've all, well, maybe not yet, but you get a large file, just a large text file. We'll say, I don't know, 200 megabytes. It's all text. You try and open it in Word crashes. This used to be the case. So what probably went wrong there is you tried to read the file. You were in a 32-bit system, and then Word couldn't finish reading it, so it crashed. So that used to be an issue. And as you get log files that are in the hundreds of megabytes, so not all companies think about small, they just log stuff. So you'll get exposure to a whole bunch of stuff, and you'll have to find ways around it. So, but where I was going with that is, think if you need to load the full file at once, or can you take parts of it, process, allocate your memory, and then load the next parts. Most of that stuff is hidden from us now, but always kind of be aware, even though we don't explicitly have to manage memory, there are ways that you can tap into it to make it more aware. And this becomes huge as you are trying to run your application out on Azure or AWS, because the more processing power and resources you have to use, the more expensive it is. So every line of code needs to serve a purpose, and this kind of makes sure your cost is down, but also you are not using more execution than you need to. So scalable services. So there's really two big ways that you can make your application grow with load. So you can either increase the resources. This one is a lot less likely to happen. So when you redesign or re-architect the system, that's a negative cost to the business, so it probably will not happen. But at some point, you're going to have to pull stuff out. So it's kind of up to you as a developer to find the most economic way to do that. And then when you start making things in smaller, more vertical lanes, we're going to call it vertical lanes, is your API only works with one data model. So there's not a lot of crosstalk. You don't reach out, like in the Spotify example, you don't go from the playlist and then ask to stream some music into that playlist. So your concerns are separated. And when it's built like that, you can spin up more of the same service, but use messaging to control the flow of who takes it. And you can, basically, you're just trying to knock out bite-sized problems, get it off the queue, get it processed, and spit back your result. So older solutions, or just people that were not thinking with the big picture in mind, when the only way you have to make your system better is to throw more resources at it, that's going to come back to the monolith. You increase RAM, you increase your CPU. So you're very limited in that environment. Those are, the two strategies. So always it's kind of like how we problem solve. Try and make solutions that deal with the smallest problem they can. You don't want to make it too small, because there's a lot of cross communication that has to happen. So there's a kind of a fine line, but smaller the better. And always build it so that you can quickly just take a bite-sized piece of data, do the work, complete it, and multiple things can happen at the same time. So message queues and events, I kind of went into a little bit more than I meant to earlier, so I won't touch on this one very much. But the architecture on this, so AWS, Azure, and Cloudflare all have a very similar thing. There's also third party if you do Docker. RabbitMQ is a good one that is open source and works nice. But basically, this give you a permanent storage for messages. And its whole job is to distribute those and keep record of those to make sure that they do get served. So you can use this if you're in a huge system. Like I know Twitch is probably going to use this for everything. So you get a request that comes in, there's a bunch of consumers on the end, which is a service, and each one does the processor's response, sends it back. So the queue basically just sits there in between. It's just stores a message. You can set things, time to live. So if something sits on there more than whatever you set, we'll say 2 minutes, it dies. So anything that it kind of keeps things pruned. If there's errors, you can have it recycle, get added back to the queue, and eventually, if it hits a limit, you can error that message out, and that's when you would want to take that and go to some sort of logger. But there's a whole lot of configuration you can go here. When you get into event-based systems, so Azure and AWS also offer something that is event. So the difference between an event and a queue is once the event is raised, there has to be a listener for it. If that doesn't get processed, then it's just gone. But a queue, again, is permanent. So both very small messages, they get broadcast out to a set of endpoints, but they go away. So where would you use things like this? So any sort of operations type software. So we're talking about logistics, like if you're running a Amazon store, or you work with a company that builds parts and you have to take things from point A to point B. They have years of data. So reporting becomes a very intensive operation, even though the data that makes it up is very small. These requests, they can eat up like all of the resources it wants to take, and then starve out the rest of your processes. So a message queue for that lets you put those requests in there. You can do the processing off of a system that needs to be performant and notify the front end. So it's just, yeah, all messages. So the benefits we get from message queues, again, it lets you scale your number of consumers. If you only need 2 consumers to keep your queue in a good throughput and service, then that's good. But the way it's built, if you need to do 5, let's say you're launching a new product, traffic is going to go crazy. But so you can, for that time period, just throw 5 consumers at it while it's busy, and then turn those off. So it helps you minimize cost. And then also, the way you've built your system, you don't have to let your consumer be your bottleneck. So now you get into things like, well, when one message happens, what if I need to do 5 different things? So there's infrastructure in place. And if you look up the Saga pattern, that will let you make sure that all the processing gets done by the different systems before that message gets completed. So there's some synchronization that has to happen. The message queues help you do that. That's probably a little bit bigger topic, because it's very complicated. So unless you have a big development team, you probably will never see this, but it's just something to be kind of cognizant of. So database optimization. So there's really a few things that we can do that helps let's do things. So full stack developers, mostly we use some the ORM. So for .NET, that's Entity Framework. For Laravel, that's Eloquent. Python has SQL Alchemy. So basically, they sit in between our applications in the database. We write our code, and it translates what we write into SQL queries. So they don't always write the cleanest code for what you're doing. So if you have a lot of times your user table is notorious for having a relationship to everything. So depending on your solution, so we'll go back to kind of the Spotify example. So your user, you have a playlist, you're listening to music, you have favorite artists. Spotify keeps track of what you listen to, how much. So already we've got 6 tables that we've linked that are not exponential, but linear growth for everything that you listen to. And ORMs are very aggressive on how they load that. So if you load your user, have eager loading enabled, it's going to try to load your user and all of your data all at once. So it'll kill your system like immediately, especially after time. Let's say your application's been alive for 1 to 2 years. All that data starts trying to get loaded. So you'll have a really peppy system to begin with, but then as it ages, a lot of applications, they get really slow. And that it's because of our ORM usage being too aggressive. And again, kind of like what I was mentioning earlier, always include pagination. Try and only load a little bit at a time. And if you don't need the data, then don't load it. So this comes into how we architect our code base. So ORMs, you have to configure things like, do you lazy or eager load? How are you going to give back your data? So the thing to do 10 years ago was make one request, populate every table you could on that request, and send it back to your front end. So the savings you were getting is you only had to make one request from your UI, but the cost was that you probably were throwing away 90% of the data that you needed at the time that you loaded. So it was a lazy way, but we got real excited because we could have one save function and one load function. So it didn't last very long, but it was one of those things that it just made your system really slow just because of all the connections. So now when you get into databases, there's things called transactions. So basically, when you need to make multiple updates to your database at the same time, but you don't want your data to be saved permanently until all of those are completed, that is what we define as a transaction. So some of the things that go along with that is whenever you read data and it's going to be part of a transaction, your database locks that row for you until it gets released. So so in the context of a web application, so you are going to lock a row to update, but anytime a request comes in for that row, it's going to block it. It can either do you can either wait until it gets freed up and then continue your code, or you can exception out. So one way lets you handle it on the front, or just gives you a way to handle it, but you have to manage, do you send it back another request? Do you wait a little bit and retry it on the code? Or in the lock and wait, so you could be making your transaction time very slow. So if you're getting 20 rows and one's locked, then you have to wait 2 seconds, then your user experience suffers on the front end, all just because you lock the row for too long. So whenever you do these things, so this comes in with multi-threading and database transactions. Always just, if you're going to lock it, just get out of it quick. So be aware. Views. So when you need to pull together data from multiple tables in your database, so let's see, do I have an example? So I'll say user, it ties to some event in the system. It ties to different web pages, different routes, and then there's multiple events. So I want these, and I'm going to access them frequently. If you're going to do that, solution so that you don't have to duplicate data and have it all together is to create views. And a view is basically a query. It instructs your database how to pull together data efficiently, and it'll keep that stored in the memory. You can even do things where you make updates to the view, and you can instruct it how to update all the corresponding tables. So it gives you a lot of flexibility. You don't increase your total storage size, but you do need to be aware that it uses a lot more memory. And also this increases your speed by a lot. Avoid using cursors in SQL. So a cursor is a way for you to iterate through a list of things. So don't ever, like rule of thumb, don't ever do anything in a database that's line by line. Always try and do your set operation. So SQL is built for set operations, not line by line. That should be handled either outside of the system. There's always exceptions, but anytime you use cursors, it kills performance on your queries. And then again, kind of coming back to ORM and stuff, compile versus dynamic queries. So if you need to do number crunching or you run a lot of the queries repeatedly, it is efficient to move those into the database either as functions, stored procedures, and objects. So these let you, so simply by putting it on the database in a project, it knows how to optimize those, as well as not having to figure out what those are doing every time you ask for it. So it's just a function call that you can call within your code base, and then you process the output. So always a theme is delegate, and then kind of bite size, try to make everything bite size and make your solutions a bunch of bite sized solutions and not one big thing. So getting a little bit more into indexing. So performance on databases are greatly impacted about how well it knows where to look for your data. So indexes provides a tool for you to associate certain combinations of columns and fields into the hashes or kind of lookups that associates your data with those combinations. So example would be, so by going back to like a user table, by convention, we always use some sort of user ID. It could be integer or unique identifier. Because it's a primary key, it will always, a database will always index that. But how often do we actually query by that ID when we're looking information up? Probably not that often. So what comes up is like the first name, last name, or social security number, things like that. So when you start using those frequently, because you haven't really told the database that that combination of columns has meaning for your data, and it will create an association for you so the recall is faster. But without that association, it has to just go and look through how it's stored, parse through that line by line for your specific columns, and then return the results, versus having those kind of optimized to have kind of a middleman that knows where that piece of storage is based on the combination. So so more examples. So like I said, the first name, last name. If you're searching for products that you have listed on Amazon, you're probably going to look at model numbers is going to be a big one. Indexing by, there's special things that you do with strings whenever you do free text search. Every platform kind of has its own pattern that you follow, and a lot of times it's an extra feature. But these greatly increase your ability to do wildcard searches, which are like look for a string that matches partials. So any sort of lookup is an expensive operation, and you want to try and get the ones that are very common knocked out. So just to give an example, so one of the tools that you can use for databases, it's called an execution plan. I know it's specific, this is specific to Microsoft SQL, but MySQL and a lot of Postgres, they all have some sort of implementation of this. So as you run your queries, you can see what operations are expensive. So I'll add a join. Let's see, can I think that one. Whoop. Equals. Okay. So this tells you what steps your underlying system has to do to return the results. Now, I won't sit here too long. Is that gonna work? Nope. Bad example. Anyway, what I was going to show here was as you add more joins onto this, how your okay, so how your execution grows. So you'll see the join took most of the processing amount. So 71% was just adding that join. So imagine what happens whenever you start getting 4 or 5 tables here. So this gives you a feel for what part of the query that caused the problem, how much time it takes, and also your CPU costs, stuff like that. So now when you get to see here the clustered index, so this was doing a primary key scan because I joined on primary keys, so it was able to find it. But when you don't have these things in here, this tool can give you ways to create indexes that will help optimize your query. So whenever you start seeing things get slow, just always look for getting more information about what you're doing, and you need to get it broke down. And profile, the execution plan is a huge thing for databases. It will probably come down the line, but it's just another thing to kind of keep in your toolbox. So I talked about views. So this is kind of a visualization of a view. So the bottom part is all the different tables. The top table is an example of when you're wanting to pull together bits and pieces of information from different tables into one solution. So that is the memory optimized, and also it utilizes your indexes to make sure that information is pulled together as quick as you can. So when you can write queries against the view that queries data here. So there's a lot of tricks you can do with views to accumulate your data. So now I'm kind of rambling on. So we have a couple minutes. I have a couple example scenarios just to kind of walk through. And these are all examples I've worked on. So I worked with a big company when I got started, but I didn't enjoy it very much. So I started working with smaller companies, and most of them, they have monolithic solutions. They didn't really hire really good developers to build it. It was kind of like people with 2 or 3 years of experience, they got thrown with doing it, and they did it the best they could. So it's not, you can't really knock on people for doing it, but after a few years, things just start creeping on you. So this example, one company I worked with, they had an application. It manages their whole internal process. So it does reporting. It does just routine database transactions. So it monitors product moving from one part of production. This is in construction of a collectible. Selection of the things that are going to go on that collectible. The point at which actual inventory needs to go on it. It manages all of that. So, but then this scenario, at the end of the quarter, the accounting team needs to pull reports. So when they start pulling reports, the whole system goes down because things are going wrong. So one of the things I had to go look at was why that happened. So the only clues I had was the timing. I knew it was the end of the quarter. And I knew that users couldn't interact with the system. So it wasn't a whole lot to go on. So even locally, you run the solution against the production database. You can see as soon as it enters the system, it freezes up. So the first clue was that the database was doing something there. So again, like I kind of mentioned before, I did do execution plan to figure out. So I saw that it wasn't even making through the first step of any query I gave it. So this actually come down to looking at the resource monitor for the database. So one of the things that you can do with the master table on any database, this goes for MySQL, Oracle, Microsoft SQL, is you can look at everything that's currently running in the system with their percentage of utilization of your resources. So what you get to see is the amount of time it's been running, who called it, what was called to cause it. So in this case, it was a stored procedure that was a report, and it had been running for about 45 minutes. So that was like the biggest clue. So why would someone run that in the middle of the day? Well, it was the accounting team needed to pull a report. So to solve that, what are our options? So kind of like I mentioned before, so we have message queues, but the system is built so that everything is in one code base and there's no way to strip it out. So there's not really a great short-term solution for it, other than you have to tell them not to run that until it's late at night. So what we ended up doing is creating a query in the database that pre-populates a table with the data that was going to go into that report. And then anytime they call that report function, it just creates an Excel document that they can download. So not ideal solution, but sometimes I just kind of want to iterate that you're not always going to be able to make the perfect solution, but if you can find ways to minimize the load on your system for when you can actually handle those things, to kind of think outside the box. Never be afraid to push against the business if things are going to be hard or kind of on the surface look impossible without throwing a bunch of time on it. So always be aware. So there's little things that we were able to do. So because the query was generated in code, so it was actually part of the ORM's fault that it was so slow, we moved that function call into the database and then used the database to do the heavy lifting of that. So, but ideally it would have been better to strip out all the reporting, put it in its own kind of package, and then have that hosted on a completely different system. So the web application and the web API are both only dealing with that, and then the reporting is dealing with something else. And the connector between those two things is, again, the message bus and then events. So I guess I'll stop there for any questions because I'm kind of rambling on. So if anyone has questions, please speak up. So I guess the important takeaways I really want you to take is just have a general feel. Always try to find tools that give you insight into your application. You won't necessarily be able to think. You can think through and have gut instincts about what might be going wrong, but you really have to find ways to measure it, and then also evaluate. Use the tools that are available to evaluate what you're trying to do. And so there's a tool for everything nowadays. So there's really very minimal that we have to invent. Don't be afraid to use very rudimentary things. So like just putting timestamps in your application, measure the start to the end. You can make unit tests that measure start to the end. Part of QA testing should include performance. So putting load on the system, making sure that when you make a web request, always look at your browser, make sure that things aren't taking more than 1 or 2 seconds. Latency becomes an issue. If you're on the same network, you really shouldn't spend a whole lot of time. Anything over a second is probably could use optimization. And then always make sure that you make meaning out of every line of code. So database, when you use databases, take the time to understand what's going on under the scenes. Don't just assume that ORM is going to give you good interaction with it. It's very quickly get out of control. And then every problem you find, always find ways to do, just tackle the smallest bit that you can, whether it's just putting a function in to solve it and then making your composition of functions. Because then these parts, as you need to replace them or update it, you're only replacing small bits. And you're only worried that the input and the output match, and the stuff that happens in between, that's where you can really find ways to make it tuned. So anyway, so any questions? I will leave it open a minute, but Stop share. So I'll throw up my LinkedIn. Please connect. Networking. I will say one of the things that I had to learn the hard way was network. So you never know who you meet. And when you go back in a few years, they may have something that just is like the super dream job. So try and keep up with the developers you like. And then feel free to reach out if you're working on any code and you just wanted a second pair of eyes on it, or help with interview type questions, just little things. I can be a resource, so don't hesitate. And it helps me to help other people because it's a whole exercise of getting better communicating and just kind of reset your brain into a different mindset. So I hope it was helpful. Definitely remember the back end is the only place that's really predictable. The client, you never know what you're dealing with. So when you do make optimizations, that's the best place to start. So yep, anyway, appreciate you guys.
Thanks, Jason. That was super informative. Appreciate your time.
Thank you, Jason. Thank you so much.